Well, thank you very much. Like Chris said, my name is Dr. Russell Keith-Magee. For those who don't know me, my day job is as the CTO and co-founder of TradesCloud. We're a software as a service for tradespeople, so plumbers, electricians, carpenters, those sort of people. But that is just my day job. In my spare time, I'm the core developer, or I've been a core developer on the Django project since January 2006. I've been president of the Django Software Foundation since 2010. The DSF is the IP, legal and fundraising arm of the Django project. What's Django? Well, it's the most popular web framework that's based in Python. For those who don't know, Instagram is a Django site. Much of Mozilla's internal infrastructure, including the plugin repository, browser plugin repository, is a Django site. Discuss is a Django site, and there's lots of other examples out there of sort of high-profile, high-volume Django sites. But I'm not here today to talk about Django per se. I'm here to get a bit meta and sort of talk about the tools and processes that are involved in writing Django as a piece of software. So I write code. I write code for Django, I write code for my day job, and I write code for fun. I've been doing this for a while. I've had 8 years as an open source contributor to a major international project, 12 years professionally. Before that, 7 years academically, closer to 10 years before that recreationally. So we're looking at about a 30-year-old programming history for me personally. And over that time, I've noticed something. My tools have gotten appreciably worse. Not universally. Some aspects have gotten a lot better. Languages, for example, are a lot better now than they were 30 years ago. Libraries are a lot easier to use and much better documented now than they have been over the last 30, for that matter, 5 or 10 years. And I'm also not talking about computers in general. Computers are obviously a lot more powerful than they were 30 years ago. I'm talking about the cobbler's children having no shoes. The idea that the people who are writing software, their tools have not gotten better at the same rate as the technology has been advancing. Public-facing UIs have gotten a lot better over time. So public user-facing software has gotten a lot better. But the tools that people are using to build those user interfaces, developer tools with a user-facing focus, that is to say, a developer-facing interface, there's been little to no improvement, and in many cases have gotten significantly worse. Now, this isn't a language-specific thing. I am a Python guy by choice. My experience is very heavily weighted in that space. But I've used lots of languages over that 30-year span, and the problem that I see is common to all of them. And what's worse is that new languages and tools that are emerging seem to be intent on reinforcing the status quo, not pushing things forward and pushing improvement. So what sort of thing am I talking about? Well, okay, here's an example that'll be familiar to some. Here's the state of the art for debugging when I really started getting serious with programming circa 1987. This is the ball and suite of tools. Some of you may recognise it as Turbo Pascal. It's a GUI of a fashion. It was the very best GUI that you could get on a CGA monitor. You can see the code that you're editing. You can see the code that you're debugging. You've got context. You can see the lines either side of the thing that you're currently running. You want a breakpoint? Well, you click on the line and you'll get it. You want to inspect a variable? Well, you click on a line, you'll get a watch window. It was closed source, at least the tools were, but then again, this is also sort of pre-internet in that sort of public internet sense, so they get a bit of a pass for that. This is what a debugger looked like in 1994 when I discovered Linux and open source. It's got one line of context, if you're lucky. There's an obscure set of commands, all based around sort of one-letter commands and whatnot. There's help if you want it, but you'll notice the one thing that it'll tell you about how to get your licensing information, how to get your copying information. It doesn't tell you how to get help.
That's not important.
Freedom, yes, of course. Okay, so that's 20 years ago. All right, we've had 20 years of open source development. This was kind of, it wasn't new to the GNU project, but the GNU project has been evolving for the last 20 years. So things have obviously got a lot better, haven't they? So what does a debugger, what's state-of-the-art debugging look like now? That's right, exactly the same. And like some sort of nefarious virus, this user interface, if you want to call it that, is spreading. Here's the state-of-the-art for Python debugging. Does it look familiar? It's not telling me. Yes. Now, okay, I'm aware of the reason why. I'm not an idiot. I am aware of the reason why this is. GDB historically comes from a time when it was console only. Console interfaces are also sometimes the only thing you've got. If you're debugging a kernel boot sequence, you can't very well pop open an X window and get some code context. As far as Python's concerned, well, they're providing the simplest possible thing that could possibly work out of the box. In terms of raw functionality, both GDB and PDB are extremely powerful engines. GDB will let you inspect literally anything in your process space. It's incredibly configurable. It's got all sorts of goodies in there. Python's debugger is essentially the same, and to boot, is actually really elegant. If you dig underneath the hood, you actually have a look inside, It's actually more of a debugging framework that just happens to have a really simple command line user interface as a proof of concept that it can have a user interface. The catch is that's the only user interface anyone ever uses. And as a community, nobody's really taken the bait and improved on that basic user interface. So why is it so? Why has this happened? Why has open source tooling not improved in the 20 years since that sort of thing popped up in the first place? Well, I have a theory, and it's all about philosophy gone wrong. The open source world has deeply embraced the Unix philosophy. And that's, in my mind, for very good reason. The idea that every tool should do one thing and do one thing well, this is a powerful idea. It encourages good design. It nicely separates concerns, which is good from an engineering standpoint, but it's also good from a community management standpoint. In particular, when you're dealing with bazaar-style development, it's much easier to do sort of control and coordination when there are lots of little independent parts, each of which are being maintained independently. In many respects, it's no different to good software engineering. You define a good interface between your components and then build the components to match that interface. The problem is that sort of a cargo cult has sort of developed around this philosophy. If everyone's familiar with cargo cults, so these groups in World War II of Pacific Islanders who accidentally had a B-52 drop a cargo load full of useful equipment on them, and they've all of a sudden started building these temples to make these more crates fall from the sky, not actually understanding what the process is involved, but going through the rituals because that's what made the box appear last time. The cult's philosophy goes a little bit like this. Unix philosophy yields powerful tools. This is undeniable. Unix toolchain is incredibly powerful. It's amazing what you can do with it. Unix tools have only ever had a command line user interface. Therefore, powerful tools only need a command line user interface. What about data that's inherently visual? What about context when you're debugging, seeing the 5 lines of code either side? What about code coverage information, visual representations of memory usage? Now, in some cases, the reason why the only thing that exists is a command line interface is laziness, or by extension, just a sheer lack of resources. Building a console interface, building a command line interface is, relatively speaking, quite easy. But console interfaces are also necessary. The composability that comes from piping one command into another is a very, very powerful idea and a very powerful tool for composing things together. But why does a console user interface have to be the end of the story? So, okay, nice idea, nice story about a cargo cult. What's the alternative? Well, let's be clear what I'm not talking about. Some of you are possibly thinking that I'm about to start saying we should also all be using IDEs, all-in-one graphical user interface tools. And you'd be wrong. Fully featured IDEs continue down the path that Borland laid out in Turbo Pascal and Borland C back in the day. Large, complex graphical user interfaces, everything done with a mouse. And they're nifty, and they're cool, and they've got all sorts of nifty functionality, but they do miss out fundamentally on the benefits of the Unix philosophy. You get one tool, the GUI. If it doesn't do it, you're screwed. If you're really lucky, there'll be a plugin interface, but that plugin interface can only do what the main GUI allows it to do. So if the main GUI doesn't expose an interface that lets you manipulate some important aspect of your project, it can't be done. Or at least it can't be done without building a completely separate standalone tool, but then you're not going to be hooking into the functionality of your main tool, so you've kind of got this little island over here that's going to survive by itself. Now, there are GUIs for Python development, there are IDEs for Python development, and they're all quite good, quite powerful type instruments, but that's not what I'm advocating for today. What I'm advocating for is that we should keep the good bits of the Unix philosophy. Have tools that do one thing and do one thing well. This is a powerful idea with very powerful and profound consequences. But when there's an opportunity for complex user interaction, so for example, if you're inspecting a progress before a task is complete, or if the output has a natural visual representation, provide that. Now, this isn't just vague theory. Beware is an umbrella project that I've been looking at this problem for about 18 months at this point. As I said earlier, I'm primarily focused in the Python world, so my tools are written in Python, and I do almost all of my testing on the Python code that I'm actually working on a day-to-day basis. But what I want to reinforce here is there's nothing particularly Python-specific about what I'm about to describe, both in terms of the tool selection, the language that I'm using to develop my tools, and so the implementation that they're being used in, and the fact that this Python tool could actually work quite well in a Ruby space, for example, with appropriate plugins and backends and whatnot around. So, as a sort of a concrete example, here's where I started with the Beware project. I picked a common problem that I have with a shocking user interface, testing. This is the state of the art for running a unit test in Python. Those of you who have got unit tests and run them from command lines, this probably looks very familiar. You have a single command line invocation. You run the test, manage.py test. It's a Django test suite. It runs the suite. A few questions though. How long has this test suite been running? How long has it got left to run? The skips, there's a great big block of skips up the top there in the start. Are they a problem? Should I be looking into that instead of investigating why I've got this large bulk group of skips? There's a fail about 4 lines down, just a one little isolated fail. Is that a problem? Should I be digging into that now? Can I dig into that now and start fixing the problem while the test suite's still running? Is it worth the effort? One of the tests raised a couple of warnings to the console. Which one was that? Most importantly, can I find out any of this before the test suite finishes running? No. Can I start fixing the problem that I know that I have? No. Well, that's not entirely true. If I turn up verbosity on the test runner itself, I can see what happens while it happens. Then all I have to do is spelunk through 200 pages of output coming spewing past on the screen to find the line of text that actually means something. No. There has to be a better way. And so that's what I built. The first tool that I built exploring this sort of basic problem was a test suite runner called Cricket. Because unless you're playing the English, test cricket takes a long time. So what does Cricket do? Well, it does exactly one thing. It runs test suites. And it gives you a visualization of the test suite while the test suite is running that gives you some structural context. Which tests are in which packages, or which tests are part of which test cases, are part of which packages, part of which modules. And allows you to browse through that. So you can collapse the tree and sort of say, well, I've got 100 tests here, but I'll hide all those and look at these ones down here. It gives you a progress meter that tells you how far you are through your test run. So you've got a little progress bar, you can see how far you are going, and when it actually is running, you see a little timer countdown giving an estimation of how long it's going to take based upon how long it's taken to run the test so far. Whilst the test suite is running, it's giving you feedback to say which tests have passed and which ones have failed. You've got green lines to say these tests have passed, you've got oranges to say that they're warnings, reds to say they're fails. There's a known failure in there as well. Which is giving you progress, and they're being updated live as the test suite is running. And you've also got, whilst the test suite is running, you can select an item on the tree and it will give you the full reason why that test suite didn't know what was wrong with that test. It tells you here, okay, this test was a failure, duration was 0 seconds, so it was a very fast test. What was the description of what the test was trying to do? What's the assertion condition that caused the test to fail? So if I wanted to, I could go off whilst the test suite is still running, I could go off to my source tree, okay, fix that one, save it, off we go. We've also got a second tab. If you look at the top there, there's all tests and there's problems. So I can see the full suite, this is all of my tests, or I can narrow it down and say, just show me the ones that are a problem, to let you sort of identify the patterns that exist. Oh, it's all the tests in my authentication framework that have failed. I must have stuffed up something there. So, reinforcing the point, this is a tool that does exactly one thing. It runs a Python test suite. Theoretically, it could run any language test suite, but I just haven't written the back-end plugins to actually go off and spawn and run a Ruby test suite, for example. Patches welcome. Okay, some other benefits. It's cross-platform, it requires 0 configuration, and it integrates easily and well with other tools. Let's dig into each of those in detail. First off, it's a cross-platform tool. It's worth noting that it uses absolutely nothing that Python doesn't provide out of the box. Humble opinion here, but one of the contributing reasons why GUI tools are so far behind in open source is that even if you restrict yourself to just Unix, you've had the GNOME QT wars in the late 90s, the Wayland Mir wars today. When you can't even agree how to draw a widget, how are you going to start having tools that all use the same user interface? And that's before you even start talking about open source working in Windows and OS X as well. So, cross-platform, these issues exist and are real. So obviously a key part of this is having a GUI toolkit that you can genuinely use cross-platform. Cricket and the Beware suite in general addresses this using TK. How many people here know of or have used TK in some capacity? All right, that's a lot more than I expected. Okay, so I don't need to go into the history of what Tickle TK is. The reason it's interesting, just for those who haven't heard about it, it's called Tickle is the tool control language. It was sort of invented as sort of a visual basic for Unix. It basically failed on that front, but where it has been very successful is in providing TK, providing this widgeting toolkit to a lot of other languages. At its core as a language, Tickle does everything in strings, or is manipulatable as strings, which means that interfacing with TK, all you need to be able to do is hand around strings, which means that you can write a Python interface to TK really easily. You just need to pass strings in and be able to handle string responses when they come back. The simplicity of that interface is what makes it interesting, because now there are TK interfaces to Perl, to Ruby, to Python, and basically any other toolkit to any other language you want. If you can get a GUI, if you can pass around strings, you can get a fully featured GUI toolkit that is cross-platform and looks native on the platforms that it's running on by just passing these strings around. So, getting a GUI toolkit for your language is a really easy thing to get off the ground. In the interest of full disclosure, it isn't a magical land of milk and honey. There are some limitations. You are dealing with a string-based protocol to a windowing system running through a scripted language that has to probably cross a language boundary as well. There can be some speed issues. Redraws can be a little bit slow if you're looking to do really, really fast refreshes, but on the scale of mildly distracting. Something you probably wouldn't want to put in the hands of your grandmother who just wants to use a tool, but we're developers, we can live with a little bit of cruft as long as it doesn't get in the way. And that's sort of the level where these sort of UI redraw problems are. It's also missing some interesting widgets, most notably at the moment the HTML widget. There is no native way to say, draw me a block of HTML. This is a surmountable problem. It's really just lacking eyeballs, something that I'm hoping to have a look at some point in the future. And TK is open source, so you can jump in and play around with this if you want. There's also some interesting windowing limitations. Due to a bug, you can't set an icon for your application under OS X. There's no such thing as a full screen window under TK, so that restricts some of the applications you can possibly run. Again, TK is open source, so there's some possibilities there. I'm not going to give a tutorial on TK here. If you want to know more, go have a look at tkdocs.com. This is one of the historical problems with TK is that its documentation was awful. TK Docs is an open source project basically saying the docs are awful, let's fix that, and has written a whole bunch of really good tutorials, library examples, whatnot, and is also completely cross-platform. Every example they give in Tcl, Python, Perl, and Ruby. So one, you can see the cross-language, this is how different languages deal with the same thing, and little warnings, in Ruby, you need to do this way, and in Python, you need to make sure this thing is always on the end of the list or whatever. But it is genuinely a cross-platform language, and the docs there are really good at exposing you to that cross-platform. Other benefits of Cricket as a tool and sort of this general approach, it requires zero configuration. It runs in your native Unix environment. If you hang around something like Django's mailing list, a not infrequent question is, how do I configure PyCharm, which is one of the big IDEs, to do X? And the thing is, that's a set of knowledge that only people who use PyCharm know, because it involves going to a particular set of menu items, looking at a particular configuration dialog box and setting things up. Cricket doesn't have that. To install Cricket, you use pip install Cricket, the same tools you use to install packages under Python normally. It uses Python's own packaging system to install itself. To run it, command line, Cricket. It's running as a command line tool. So it's being invoked from the command line. So it's inheriting your Unix environment when it runs. You don't need to configure anything in Cricket in order to get all of that output. It's just inheriting the environment that it started from. And as a result, that also means that it integrates well with other tools. You don't have to give up the Unix pipes philosophy to adopt this kind of tooling. So, for example, when you were using Cricket to run your test suite, you could check a box and say, yes, and by the way, when I run this test suite, I want to also generate coverage information. So it will go off and turn on the necessary flags and run the coverage information in the background, generate a coverage file, and you can then go and inspect that, using, of course, the state-of-the-art tool for looking at coverage information in the Unix world. Of course, lines 27 to 29 and 33 to 34, how could I be so foolish that I didn't write a test covered those lines? Or would you rather look at that? This is a second tool called Duvet. It's for giving you good coverage. I like puns. So, which would you rather see? A list of line numbers that you haven't passed in your test, or a graphical representation of the file that highlights the lines of the files that you haven't tested? And because this tool is running persistently, up in the top corner, there's a little thing that says, okay, we've currently got 47% coverage, but the good news is it's up on the last time we ran it. Over on the right-hand side, you've got your tree of all the source files telling you which files are well covered and which ones aren't. And you can work your way through that tree and have a look and inspect all your coverage information. And again, it does one thing, and one thing well. It just displays your coverage information over the source tree that you're working with. Now, okay, I am being a little bit unfair here because coverage does have better ways of reporting, one of which is as a web page, which does raise an interesting question. Why not use a web interface for this? Well, in some cases, a web interface does make sense, but I would argue that it isn't the global solution. First off, anything that's going to have a web interface needs to have a server or it needs to be generating a static file. Either way, you're going to be generating a file and loading into a web browser, which is sort of a bit of handling of a large and unwieldy URL. It can be done. It's a little bit awkward, but we're developers, maybe we can live with that. Second problem is live updates. Cricket will update the second that the test happens. A test passes, boom, icon goes on in the user interface. Again, this can be done in web interfaces, but we're still coming to terms with the real-time web. There are things you can do, but we're certainly not there in a state of maturity where it's going to work across every browser in every development environment and work reliably in that sense. Lastly, but most importantly, I'm personally not a believer that web browsers are ever going to be able to produce user interfaces that are superior to native tools. Native Twitter clients have a completely different feel to web clients. And that's not something that I'm personally willing to give up. Has anyone ever actually found a web-based text editor that they'd rather use in preference to VI, Emacs? There's a reason we use native tools. There's benefits to being in a native tool set and not viewing the world through the inside of a tab of some other application. Will this change in the future? Possibly, maybe, but it's definitely not true now. And given the state of tools at the moment, I don't want to spend my life peering through that little window. So that's my pitch. I don't propose that I've got all the answers. Beware is just my sort of attempt to hack away and solve or scratch a couple of itches that I've got personally. Mostly the reason I'm presenting here today is sort of to get the idea out there that our tools can be a lot better. I'd love to see a lot more work in this space, either as part of Beware if someone wants to contribute something, or even completely separate projects. Because frankly, I'm a developer and I'd like my day-to-day work to be a lot better. I'd like to see my tools getting better rather than progressing along the same path they've been at for as long as I can remember. So, thank you very much.
We have a minute or so for questions. So does anyone have a question to inflict upon Russell? Yes.
How tightly coupled is Duvet to Python testing engine, or could it be easily adapted to, say, other?
Okay, so it's currently essentially using PyCoverage, which is Ned Batchelder's toolset. I haven't aggressively gone out of writing a backend that separates the format it's reading from the format it's getting. I'm actually leveraging a lot of the capabilities that Coverage actually gives you out of the box. But at least in theory, there's no reason it couldn't read a different format. So I'd certainly be interested in seeing if there is a common format that Coverage isn't using that another language could make use of, then absolutely, it shouldn't be too hard to tag in. This is the thing about these GUI frameworks, is that it is a GUI representation. So as long as you've got some lingua franca in the middle, some format that both versions can read, then it shouldn't be a major drama. Hey.
I had a similar question, but about the unit test part of it.
Mm-hmm.
What kind of, where is the boundary between the GUI tool and the backend running the unit test? Do you run the command line tool and the Cobblers?
Okay, so what's happening behind the scenes is there's a main process that is often running, which is the GUI, and then when you run the test suite, it spawns a child process which runs the test suite. And the configuration, this is one where there is a really good back-end configuration for this, because I've got to run both Django test suites and Python unit test suites, which have slightly different invocation requirements. But essentially there's an on-the-line text-based protocol that you can run that test runner, and it will spew a bunch of stuff to the screen in a completely unusable format, but in a parsable format. It's a bunch of pre-test and post-test JSON strings, basically. If you can write a test runner for your language that spits out data in that format, Cricket will eat it up right away. So, and it's a relatively simple, the Django test runner is something like about 40 lines of code to do the whole thing.
Because the PHP unit output format is very similar to what you showed on the screen for the Python test. And I was running one just yesterday, but one right now to figure out what the hell is actually on.
Right.
So that would be a good thing I was writing.
Sure. Can we take one more question? Yep.
Where's the pun in beware? I mean, there's a word for where. Is that what you were driving at?
No, it's beware. The Ides of Python. Yes. Brutus is an honourable man.